Hello everyone, welcome back to Math Pals.
In the previous class, we have discussed about the basics of quadratic equation. In today's class, let's see how to examine the nature of the roots of the quadratic equation and solve few sums related to it. What do you mean by the roots of the quadratic equation? As we know, every quadratic equation gives two values of the unknown variable which is present in it, and these values are called the roots of the quadratic equation. This is also known as the solution or the answer. In the previous class, we have seen the expression b square minus 4ac, that's a discriminant of the equation ax square plus bx plus c is equal to 0, and this is what decides the nature of the roots of the quadratic equation. Let's see the possibilities of this discriminant. The possible values of the discriminants are b square minus 4ac is equal to 0. The second one, b square minus 4ac greater than 0, or b square minus 4ac less than 0. When the discriminant b square minus 4ac is equal to 0, then the roots are real and equal. And in the second case, when the discriminant is positive, that is when the discriminant is greater than 0, then the roots are real and unequal. And in the third case, when the discriminant is less than 0, that means the value of the discriminant what you are getting is a negative number, then your roots are imaginary. So, when the discriminant is equal to 0, the roots are real and equal. And when the discriminant is greater than 0, the roots are real and unequal. When the discriminant is less than 0, the roots are imaginary. Now, let's check the nature of the roots of the quadratic equations without solving it. The solution, how to find the solution of a quadratic equation, that we will be discussing in the next class. So, let's check this quadratic equation. So, you have to compare the quadratic equation, given quadratic equation, with the standard form of the equation. So, what's the standard form? As we have seen it, ax square plus bx plus c is equal to 0. And here, you need to compare these two equations and find the values of a, b and c. So, you will get the value of a as 7, b as minus 9 and c as 2. We have got the values of a as 7, b as minus 9 and c as 2. Let's substitute these values in the discriminant expression. What's the discriminant? D is equal to b square minus 4ac. So when you substitute, you will get this as b square. What's the value of b here? It's minus 9, the whole square, minus 4 into, what's a? It's 7 into c is 2. So that's equal to square of minus 9. That's 81 minus, when you find the product of these three terms, it is 56. Subtract the values here. You will get it as 25. And this 25 is greater than 0. So we have got our discriminant greater than 0. When the discriminant is greater than 0, the nature of the roots are real and unequal. So we can say that the nature of the roots of this particular equation is real and unequal. Now let's consider another example. 25x square minus 10x plus 1 is equal to 0. The values of a, b, c are a is 25, b is minus 10 and c is 1. Substitute the values of a, b and c in the discriminant b square minus 4ac. You will get 25 square, minus 10 the whole square minus 4 into 25 into 1. So that is 100 minus 100. it's equal to 0. So you're getting the discriminant as 0. When the discriminant is 0, the nature of the roots of the equation is real and equal. So in this case, the nature of the roots are real and equal. Consider another example. 2x square plus 8x plus 9 is equal to 0. Compare this with the standard form. Ax square plus bx plus c is equal to 0. So the values of a, b, c are a is equal to 2, b is equal to 8 and c is equal to 9. Let's substitute these values in the discriminant. B square minus 4ac, you will get it as 8 square minus 4 into 2 into 9. So that's equal to 64 minus 72. That is equal to minus 8. So this is a negative number. So that's less than 0. So your discriminant is less than 0. When the discriminant is less than 0, your roots are imaginary. So your roots are imaginary in this case. Roots are imaginary in this case. So from the above examples, you have seen how to examine the nature of the roots. Now let's see few of the sums and solve and find the missing value here, k or p, by using the above property. The condition for these two questions is given as the discriminant is equal to 0. When the discriminant is 0, how to find the missing term here? So you have to find the values of a, b and c as previously how we were finding. The same way, the value of a is equal to 3, b is equal to minus 6 and c is equal to k. Now substitute these values in the discriminant and apply the condition. So that is b square minus 4ac is equal to minus 6 square minus 4 into 3 into k is equal to 0. That's equal to 0. That's a condition given here. So this is 36 minus 12k is equal to 0. 36 is equal to 12k. When you simplify, you will get the value of k as 3. So here the condition was the discriminant is equal to 0. So by using this property, we were able to find the value of k, and the value of k is equal to 3. In this question also, as the discriminant is equal to 0. Find the values of a, b and c. The value of a is 1, b is equal to 4 and c is equal to p. Substitute these values in the discriminant, that is b square minus 4ac. You will get 4 square minus 4 into 1 into p, and that is equal to 0 by the condition. So you will get this as 16 minus 4p is equal to 0. 16 is equal to 4p. Cancels 4 and 16. Here you will get the value of p as 4. That's all for today. We'll see you in the next class with another topic of quadratic equations. Thank you.